Hello everybody, welcome back to our channel. In this episode we're going to be working on a PHY7B torque practice problem. The problem goes as follows. So we basically have a disc 20 centimeters in diameter and there are 4 forces being applied on this disc, and we have to figure out what are the torques due to each individual force and what is the net torque about the axis of rotation. So as you can see, I've written the figure here in my notes, so let's just go ahead and work this out. So the equation that we're going to be working with today is this equation, the torque equation, which is a moment arm times force times sine of an angle. And just by looking at this equation, we're not even looking at this figure yet, we can see that in order to have a torque, we have 3 requirements. So 3 things need to happen in order for us to have a torque due to a force. The first requirement is a force. Of course, if you have a system, if you have a bar, if you have a wheel, if you have something and you're not applying any forces to it whatsoever, now that wheel is just not going to start turning by itself. That's just not going to happen. If you want to have a torque on your system, then you do need a force. Otherwise, nothing is really going to happen. This will be 0, everything will be 0, no torque with no force. The next thing that you need is a moment arm. A moment arm represents 2 things. First of all, it represents that we need to have an axis of rotation. So if something is gonna start rotating, we need an axis of rotation. So it's gonna start having angular momentum with respect to what point. So what's gonna be that axis? And R itself, the moment arm, is the distance from the axis of rotation to where the force is being applied. Which means that if R is equal to 0, then the entire thing is equal to 0. And the third thing that we need as a requirement is that if you have an R and you have an F, they can't be parallel to each other, because if they are parallel to each other, then this is going to be either 0 or 180, and this is going to be 0, so you're not going to have a torque. So every single time from now on that you're wondering, does this force generate a torque, you need to remember the 3 requirements. Do I have a force? Check. Do I have an R? Check. Are they parallel? If not, check. And if all of the requirements are met, then yes, you have a torque. So let's just go ahead and put this, into practice. So let's do this in order. So force 1 is this force right here. So I'm just going to go ahead and write the definition. So the torque due to force 1, it will be torque 1 is equal to moment arm 1, F1, sine of their angle. So let's just go ahead and check things out. Do we have a force? Yes. Do we have an R? Is there a distance from the axis of rotation to the force? Yes, we do have a distance. So this distance is actually the radius of the disc. So if the diameter is 20 centimeters, then the radius is 10 centimeters. So R is just going to be equal to 0.1 meters. The force is 30. Now, are these parallel? So this would be R1. And these are not parallel. In fact, they make 90 degrees over here. So this would be sine of 90, which is equal to 1. And then this number is going to be equal to 0.3. No, to 3, I'm sorry. So 3 units are newtons times meters, so a force times a meter, and we need a direction. So this is just the magnitude of the torque. We do need a direction, and for direction we're going to be using our right hand rule. There are several ways to do the right hand rule. I just do it hand on R, twirl towards F, and that's going to give me into the page. So direction is going to be into, which is a little cross. So now the second torque is R2, F2, sine of their angle. So where is F2? F2 is over here. So we have an F. However, look what's happening here. If I try, so for R1 I was able to draw this vector, right? what happens to R2? F2 is being applied exactly here at the pivot point. And what that means is that if I try to make an R, then what is going to be the magnitude of this vector? It's going to be 0, right? I can't draw a vector that starts here and ends here. So for that reason, this is just going to be equal to 0 times 40, times whatever angle. But because I'm multiplying everything times 0, then this is going to be 0. One of the requirements was not met, therefore, even though we have a force, we don't have a torque due to that force. Now, third force is F3, which is over here. So for the third torque, it's just going to be R3, F3, sine of the angle. So we do have an R because I can, in fact, draw a vector that starts at the pivot point and that ends at the tail of F. And this vector is 5 centimeters long, so that is going to be 0.05. Yes, 0.05 in meters. So that will be our R, and then our F is just going to be the 20 meters. We do have an F. Now, are these two parallel to each other? No, they are not. We have 90 degrees between both of the vectors. So this is just sine of 90. So this is just going to be 1. In which direction? Well, if you use your right-hand rule, then you'll see that it's just going out of the page. Now the last torque, let's see, the last torque is F4. Oh, here it is. So just by definition, that is just R4, F4, sine of the angle between them. So we do have an R. It's just a vector that starts over here, ends over here. And R is equal to 5 centimeters, so that is again 0.05 in meters. The force is equal to 40 newtons. We do have a force, and the angle between them, it's given to us in the problem, is actually these 30 degrees right here. So let's just go ahead and write that. So if I just multiply everything because all of the requirements are met, let's just do 0.05 times 40 times sine of 30 is equal to 1. So 1 newtons meter, and then direction, again using the right hand rule, hand on R, twirl towards F, that is going to be out of the page. So out of the page. And there we go, final answer. Torque 1, 2, 3, and 4. So now the next part of the problem is what is the net torque? So the net torque by definition is just the same as with the net force, where the net force is just the addition of all of the forces that you have in a problem. Well, the net torque works exactly the same. A net torque is just the addition of all of the torques that you have going on in your problem. So the only thing that we have to be careful with here is that we have two torques going on one direction, one torque going on the other direction. So because they are going on opposite directions, you do need to be mindful of that and not just literally add these numbers. Because if you add these numbers, you're just going to get 5. But then what's going to be the direction of that? You're adding, adding in and out of the page together. It's just like adding left and right. One of them needs to be minus to symbolize the fact that they're going in different directions, right? So in standard units, into the page is usually negative and out of the page is usually positive. But so long as you are just making a difference between your ins and your outs, you're gonna be fine. In this case, we have just 3 numbers and they're very easy. So you can see that if you have 3 going in, 2 going out, then the result is just gonna be 1 newtons meters going in, because the other 2 are just going to get canceled out. So that is just going to be our net torque. But if you're working with anything more complex than that, in which you have more numbers and you just don't want to get into an issue, then just remember that the ins need one sign, the outs need the opposite sign, because otherwise you would just get a 5 and that would be completely wrong. we do need to distinguish in versus out. And I think that was the most challenging part of this part too, honestly, that people would just add this up. But no, because torque is a vector, and vectors have directions, and directions actually matter just as much as the magnitude itself. So anyways, I hope this video was useful. If you found it useful, please leave a like and subscribe. It helps this channel a lot, and I'll see you guys on the next